So the first speaker who will represent his material is Dr. Motohiko Nishimura.
Okay, here we go. Thank you very much for your kind introduction. My name is Motohiko Nishimura of Kawasaki Heavy Industry. First of all, I'd like to express my gratitude to make a presentation on this program. And daily, we have support from NEDO and METI Japanese government, and also from support from the Australian government. We really appreciate about that. So while you may associate Kawasaki with motorcycles, we have a broad spectrum of technologies for energy and transportation, equipment such as ships, aerospace, rolling stocks, distributed power generation systems, precision machinery, and robots. By applying such technologies, we have been developing products that are necessary for realization of hydrogen energy supply chain, ranging from hydrogen production to transportation, storage, and utilization. Currently, the world is moving toward decarbonization, and mass hydrogen utilization has been highlighted. This is because energy system only with renewable and battery storage has a limit for energy scale, facility cost, and applications. Liquefied hydrogen, which Kawasaki is promoting, enables large amount long-distance, long-term transportation and storage of energy and connects multiple sectors. Also, extremely wide range of industries are involved in hydrogen supply chain and demand field, which create a virtuous cycle for environment and economy. Kawasaki aims to contribute to achievement of decarbonization as a solo company in the world that owns the full supply chain technology for production, transportation, storage, and utilization. Kawasaki is one of the founding members of Hydrogen Council, launched at the World Economic Forum 2017 in Davos. Hydrogen Council is a global initiative of leading companies with a united vision and long-term ambition for hydrogen to foster the energy transition. The council, which started with 13 companies, has now grown to include 109 companies and is working vigorously to promote the deployment of hydrogen and expand the hydrogen market. Hydrogen Council has shown the Hydrogen Introduction Vision 2050 in their report. According to the report, hydrogen market will scale up to $2.5 trillion and create 30 million employment in 2050. Also, hydrogen would meet 18 of total final energy demand. Thus, hydrogen has a big potential and could be the next game changer in the energy system. Kawasaki is working to establish hydrogen energy value chain to supply hydrogen stably, affordably, and safely to Japan. This slide shows potential of carbon dioxide-free hydrogen supply chain to Japan. Hydrogen can be produced from various sources and may enhance the energy security of Japan. We are discussing with many stakeholders to realize hydrogen supply chain. From the perspective of cost and energy security, we are focusing on Australia, which has abundant resources and the voyage route is safe. And this is a concept of international hydrogen supply chain that Kawasaki is promoting. We are aiming to develop hydrogen supply chain, producing hydrogen overseas from affordable resources and transporting to Japan in the form of liquefied hydrogen. We have selected liquefied hydrogen as an energy carrier, hydrogen carrier. This is because liquefied hydrogen is non-toxic and clean. It is also highly pure and can be supplied directly to fuel cells after evaporation. Therefore, it doesn't consume energy when it is utilized in Japan. We believe that a viable transition pathway to a green hydrogen industry will be to focus on production of hydrogen at scale using fossil fuel and CCS technology, allowing green technologies to scale and become economically viable over time. Kawasaki is working together with partners in a pilot demonstration project to establish an international hydrogen supply chain between Australia and Japan, targeting its commercialization. In order to deliver environmentally sustainable hydrogen energy, carbon dioxide produced as a byproduct of the process must be captured and sequestrated under the ground or under seafloor. This means a key element to the project is carbon capture and storage, CCS. Australia is one of the most advanced countries in terms of CCS. In Victoria, CarbonNet, a CCS project, is being promoted jointly by the Australian and Victorian governments. We are collaborating with CarbonNet project and will leverage CarbonNet CCS infrastructure, as the hydrogen supply chain project is the most likely foundation customer of the CarbonNet project. Some of you may be concerned about the life cycle carbon dioxide emissions of coal-derived hydrogen supply chain. Therefore, I will introduce life cycle assessment reported by Mizuho Information and Research Institute. This figure shows well-to-tank carbon dioxide emissions in each hydrogen production from renewable energies and Australian brown coal. In case of using brown coal, CCS, brown coal is referred as lignite in this figure. So in case of using lignite, CCS is engaged. According to this study, carbon dioxide emission of liquefied hydrogen made from lignite with CCS is comparable to that of other renewable originated hydrogen. This slide shows structure of a pilot hydrogen supply chain between Australia and Japan. The pilot project will be demonstrate coal gasification and hydrogen refining at Lateral Valley in Australia. Hydrogen liquefaction and storage of liquefied hydrogen at Hastings, maritime transportation of liquefied hydrogen from Australia to Japan, and unloading of liquefied hydrogen in Japan, Kobe, in 2021, this year. The pilot demonstration project is divided into two portions and is being promoted by two organizations, Hystra and HEA, respectively. Hystra is in charge of blue-colored rectangular portion, including hydrogen production from Victorian coal, maritime transportation of liquefied hydrogen by ship and receiving terminal in Japan, and of which have technical hurdles of overcome. All of which have technical hurdles to overcome. On the other hand, HEA is in charge of the orange-colored rectangular portion, including hydrogen refining, land transportation, liquefaction, and export terminal. This portion will play an important role in getting social license for hydrogen in Australia. So hydrogen gas production via the gasification of Victorian coal has been started in Lateral Valley. The plant is constructed and operated by J-Power, while J-Power applies their own coal gasification technology, which has already been attained commercial scale for bituminous coals. The project members announced the commencement of operations at both Victorian states, Lateral Valley and Hastings Port of its world first integrated supply chain on 12th March 2021. The site in Hastings Port is shown in the next slide. That's it. So this picture shows the hydrogen liquefaction site in Port of Hastings. Pressurized hydrogen is transported from Lateral Valley by a truck and fed to liquefaction plant that cools hydrogen down to minus 253 degrees centigrade. Liquefied hydrogen is transferred to a cryogenic container trailer. The container trailer goes to the jetty nearby, and then the liquefied hydrogen is loaded onto the hydrogen carrier ship shown in the next slide. Please see this. So this is a computer graphic of the liquefied hydrogen carrier called Suiso Frontier, developed and used in the pilot project. This carrier has been constructed in our Kobe works. Its cargo tank has a double wall structure with vacuum gap in between to prevent evaporation of liquefied hydrogen. This 1,250 cubic meters tank could transport 75 tons of liquefied hydrogen in one voyage. And this is a real photo of the ship. So please show left-hand side bottom. The launching ceremony of Swiss Frontier was held December in 2019. And please look at the right-hand side bottom. In March 2020, the cargo tank was mounted and installed on the ship successfully. The tank diameter is 10.5 meters and length is 24 meters. With such a large dimensions, although the installation accuracy in lateral and longitudinal directions are several millimeters, very precise installation. Sea trials are ongoing since last October. The first delivery of liquefied hydrogen from Australia to Japan is scheduled in this year. The construction of the liquefied hydrogen receiving terminal in Japan was also completed in May 2020 on the Kobe Airport artificial island. Currently, the trial run is in progress. Ship-to-shore transfer of liquefied hydrogen using loading arm system will be demonstrated at this terminal for the first time in the world. So, looking back to the development of LNG equipment, it took a long time for scaling up, say something 20 or 30 years. But with our great deal of know-how for LNG and liquefied hydrogen equipment, and also with evolution of simulation technologies, we could accelerate the development of scaling up of liquefied hydrogen equipment. From 2019, we started development of scaling up technologies. We are planning to develop 40,000 cubic meters of ship cargo tank and 50,000 cubic meters of onshore tank. Our partners are also developing other essential equipment for large-scale supply chain, for example, loading arm and pump. Okay, so Oshita-san also picked up this picture in his presentation. I would like to mention about the utilization of hydrogen energy. So, with regard to the hydrogen consuming facilities, we have been operating a hydrogen-fueled gas turbine cogeneration demonstration plant on Kobe Port Island since 2018, jointly with our partners. Our partners' names are shown in the red characters on the slide. This demonstration project aims to verify the feasibility of supplying both electricity and heat in a city area of the hydrogen gas turbine. So in the demonstration, the gas turbine uses 100% pure hydrogen as a fuel and supplies electricity and heat to the City Medical Center General Hospital, sewage treatment plant, International Exhibition Hall, and Sports Center, all located on the Kobe Port Island. This is a world-first project in the city area. Following successful demonstration of 0 to 100% flexible fuel technology with wet low NOx system, we announced successful technology verification of 100% hydrogen-fueled gas turbine operation with dry low NOx combustion technology, which has higher efficiency as compared to the wet low emission technology. So this slide shows about that dry low NOx emission technology and its combustor photograph. In July 2020, Kawasaki Heavy Industries and Obayashi Corporation, general contractor, have announced that a dry low NOx emission hydrogen gas turbine system has been developed. As shown in this picture, Kawasaki developed the micro mix combustion technology. The technology verification test started in May last year. Was succeeded, and it was success in the world first case. The water injection method previously used to suppress NOx emission deteriorated electrical efficiency because of evaporation of water in the combustion. In comparison, use of the dry low NOx combustion method improves the electrical efficiency and NOx emission values at the same time. Okay, now I come to the conclusion. So I'd like to emphasize the importance of the carbon dioxide-free hydrogen supply chain for accomplishing decarbonization. Hydrogen from fossil resources such as natural gas, coal, etc., linked with CCS will realize vast energy supply. This contributes to stable energy supply and security. Moreover, hydrogen utilization emits no carbon dioxide. Thus, hydrogen is expected to play an essential role in the decarbonization. Why the use of hydrogen brings industrial and economic growth? Lastly, hydrogen products started from fossil fuel will be shifted to the renewable energies in the future. This may realize sustainable energy society. Thank you very much for your attention. That's all I have to mention at this moment.
Thank you, Dr. Motohiko Nishimura, for your presentations.
ネド